So what I want to look at this morning is if we go over to Moodle and go into the CI/CD section, which is here. Then I've put up a set of slides which is concerned with looking at CI/CD in the context of a web API. And you'll notice that what really we're going to be talking about here, because we know all of the pieces of this jigsaw at this stage. We know about web API testing. We saw that last week and in this week's lab. We know what CI/CD is all about. So we're just bringing those two pieces of knowledge together in order to look at CI/CD in the context of web APIs. So we have the fundamentals and the foundations, if you like, and tying them all together isn't going to take a massive step. But there are a few issues that I need to cover with you. So I'm going to walk through these slides, slightly less structured lecture today, if I might put it that way. You see what I mean by that, because we're going to be looking at code and stepping our way through it and looking around a node project so that I can just highlight certain issues to you. Now, I did say to you this week that this week's lab was the last lab that you have to hand up, and that's true. We will have a lab next week, and next week's lab is very much about preparation for assignment 2. And really, a lot of what I'll be looking at today will be linked to that lab next week. So if we work our way through the slides, I guess. So, you can see straight away now that the headline is assignment 2, but it's by way of kind of background or context for assignment 2. And so when we're doing web API development, and this is what you're doing in the web app dev module, you might be aware, or I guess you should be aware, that what you're actually doing is, in order to run your web API, you're using a combination of something called NodeMon. NodeMon is a utility that watches for any changes in your project's file system, in particular the source folder. And if there are any changes, then it re-executes, or it tells Babel Node to go away and recompile all of your source code files. And after recompilation, it then runs the compiled files on the Node platform. That's what's actually happening in the background. Now, if I switch over to VS Code, what I've got here is a fairly up-to-date version of the web API that you are developing in the web app dev. I've taken out some of the auth stuff though, so maybe it's up to last week's, what you would have been doing last week in the web API labs. So, this should look familiar to you. So if I look inside the SRC folder, then there isn't, in the API folder, it's broken up into the different endpoints. And inside in the movies, for example, we've got our Mongoose schema. The index.js is where we have the various endpoint implementations. Okay, so this should all look familiar to you. So that's what I've got. And in addition, I've got some tests, which are here. And I've got quite a lot going on inside in the package.json. If I open up package.json, and for now, if we just look at the npm start Just going to pause for 1 second now. I'm just wondering if there's a Slack message that's come through there, and I'm not sure if it's linked to what's happening. Is it? No. Can I just check that people can hear me and see my screen? I didn't get a response. I wonder.
Yeah, we can.
Okay. Right. What I was just saying there is, see, when you do npm start, this is the script that you're running. So as you know, what it's doing is it's really executing nodemon, and nodemon is watching the file system, as I said, for any changes. But nodemon executes Babel node, and Babel node, as you know, is a utility that compiles modern JavaScript and converts it and generates a ES5 version of that JavaScript. And eventually then what Babel node does is, once it has compiled all of your source code, it passes it to the node runtime, and the node runtime then executes your code. But the node runtime needs to work with slightly older JavaScript than the kind of modern JavaScript that you're writing. Okay, that's what's happening when you're doing your web development. You've got nodemon running behind the scenes. That clearly, though, is not suitable for a production environment. We can't have this kind of nodemon monitoring the file system in a production environment. So what we need to do is we need to essentially build our Express app, or produce a static version of our Express app. Again, using Babel to help us to do that, to generate the built version of our Express app. And that built version then is what we can run in our production environment. So yeah, Babel will take care of that for us. But you know, we've got to somehow generate this built version, and we do that using Babel plus some other utilities in our package.json. So if I go back, you can see here now I've got quite a lot of scripts that I've added to my script section in my package.json. And here I've got a build script. Now, so what the build is doing is it's executing this. So what's npm run all? npm run all, if I scroll down to my dev dependencies, I've got quite a number of new dev dependencies added on to this project as well, and I'll kind of explain them as I need to. So one of the dependencies that I've installed is npm run all. You can see it here. And what npm run all is, it's a node utility, and it allows us to execute a sequence of scripts. So if I go back up to where I'm using it, which is here, when I do npm run build, what's actually going to happen is it's first of all going to run a script called clean, which you can see here. Talk about that in a second. Then it runs a script called compile all. Compile all is, there's compile all. There you can see it there. Compile all. In turn, it executes a number of other scripts. And specifically, it's saying run the compile model script first. Where's compile model? That's up here. Compile models, plural. Compile models equates to executing a number of other scripts. One of them is compile movies model. Compile movies model. We'll get there eventually. Here's compile movies models. And what that does eventually is it calls the Babel compiler. And it asks the Babel compiler to compile the code inside in this folder. That folder corresponds to this folder here. So it essentially compiles these four files, sorry. And it puts the output of those compiled files into a folder called build and into a subfolder called API movies. In other words, this folder structure here mimics the source folder structure. So what I should have, if I look here, you can see my build folder. And if I drill down into it, it does have an API subfolder and a movie subfolder. And the individual files within this subfolder is the same set of files as is in the kind of source, if you like. The difference is that the code here is very much ES5 code. And if we just glance at it for a second, you can see it's actually quite old kind of JavaScript. But this is the JavaScript that the Node platform can execute. The Node platform cannot execute. So the file that we're looking at here, its equivalent is this one. This is what we write, but it's much more modern JavaScript, and Node hasn't caught up yet, so to speak. So we have to compile the JavaScript that we write back down to ES5 JavaScript. And that's what's going on inside in my package.json when I do the npm build. If we go back to package.json again, essentially what this does is, and in particular, this part of it here, if you follow, the various references from one script to another, essentially what I'm doing here is I'm running each of these compiles, and each compile is responsible for taking one folder within my overall source code and compiling the individual files within that folder and putting the output of that compilation into a corresponding subfolder within the build main folder within this, where's build gone to? Here within this kind of build subfolder. So the build folder, its various subfolders will be a mirror of the folder structure that we have in our source code. And so you can see at the, if we look at, there's an authenticate subfolder, which corresponds to this one up here. There is a DB subfolder, and so on and so forth. The node modules have to be copied in as well. We don't have to compile the node modules. And so here are the node modules that are created when we do the npm install, but we have to copy that entire folder into our build folder as well. We don't have to compile them. All we need to do is copy them. And the copy is actually, if we study it, the copy is done here. And just as we're on it, to do the copy, I'm using a utility called NCP. NCP is another dev dependency that I've installed. There you can see it there. NCP is utility for copying files from one folder to another. Now, why am I using NCP? Why don't I just use CP? CP is the Mac command for copying files from one folder to another. So I could have just as easily replaced that with CP, and that's going to work for me. The problem is, if I give you this project and I ask you to run npm install, and then I ask you to run npm build, and you're running your you're using a Windows-based operating system, then CP is not going to work because I think the command is COPY on Windows. Now, okay, I can give you instructions to say change the CP to COPY, and then it's going to work for you. But what we prefer to do is to provide a package.json which that is platform kind of independent, that is operating system independent. And that's where NCP comes in. There are a small few differences between Windows and Mac when it comes to writing scripts. Another one is if we want to remove a directory as part of a script. Now, on Mac, the remove command is RM, whereas on Windows, it's DEL for delete. And that's actually relevant to here. I've got a script called clean, and the purpose of the clean script is to essentially delete the current build folder and create an empty version of the build again. And you can see that I'm actually calling clean here. When I do an npm run build, first thing that happens is the clean script runs. And here is the clean script. But just as with the copy, if I'm only using this project myself, then I can replace that rimraf there with RM, because RM will work for me on Mac, but it won't work for you on Windows if you're using Windows. So is there a platform independent utility that deletes or removes folders? There is, and it's the utility called rimraf. And rimraf is another one of the dev dependencies that I've included here. So where we started with all of this is I need to be able to automate the building of my web API, where building means compile all of the source code and generate an ES5 equivalent of that source code, put all of that into a folder, which I've decided to call build. But critically, the build folder, its subfolder structure has to mirror the subfolder structure of your source code. And the reason for all of that, of course, is that here's the index.js that's this is the index.js that instantiates our Express app, and whereas we have import statements in our source code, we'll have equivalent statements in our compiled code, but those equivalent statements in our compiled code are going to be referring to subdirectories, and you can see them kind of appearing here. Okay, now, and the other point is that, at least as far as I could work out, Babel, you can't tell Babel to compile a whole folder substructure and expect it to output that substructure as well. It doesn't understand, it's not able to navigate down through a whole hierarchy of folders, find JavaScript files, compile them, and output those, the output of that compilation into an equivalent subfolder structure in the build main folder. It's just not able to do that. You have to kind of step it through it. That's why I've got so many individual compiled scripts here for essentially compiling each individual folder within my folder structure for my web API. Right. So that's how we do our build, how we automate the build using Babel and a whole series of scripts in our package.json, and also some utility, some node utilities that allow us to make our scripts platform, our operating system independent. Go back here again. So the upshot of it all is I can now do something like npm run build. And if we watch what's actually happening, what it's doing is it's going through each of the individual compiles and also doing some copies, as in it's copying the node modules from my source over into the build folder. And if you just look at these, you can see it's kind of telling us step by step as to what it's doing. So it has now generated the build folder, and this build is a runnable version of my web API. I can actually run that now. And I've got a script in my package.json that runs it for me, just for convenience. So I've got a script here called start prod. And if we just ignore this bit for a second, essentially the essential part of this is here at the very end, where I go node, I'm telling node run the file called index.js in the build folder. And that's the index.js that instantiates my Express app. Now, what's going on to the left here is I am initializing some environment variables, because node is not going to pick up the .env file at all. I don't copy the .env file into the build folder for security reasons. So instead, I need to initialize the relevant environment variables on the command line. And this is a common thing, really. But the way you initialize environment variables from the command line, yet again, is slightly different for Mac as opposed to Windows. So we need a platform independent way of doing that. And there is another utility called crossinv. And that utility allows us to essentially initialize environment variables in a operating system independent way. And that's what's going on here. Crossinv is yet another dev dependency that I have installed. In fact, I've made it, it's not a dev dependency in my case. I've had to make it a dependency, which you can see here. That's the only exception now of the those utilities that I've been talking about, because I'm using crossinv to kind of in my production environment as opposed to my development environment. So if I do an npm run of start prod, where is start prod? If I do that, that will start up my Express API. So let's prove that. Actually, is this going to work? Let me just check. Let's see. Let's try it. This may not work now because of I need a local MongoDB server to be running. Okay, I think it's okay. Now, I have a separate terminal here where I did actually start my MongoDB server. That's what's running here in the background. And let's see if I can actually send a GET request now to my production version of my web API. So it should be localhost 8080. Let's see. And if I go /API/movies, Oh, sorry, wrong port. Okay. So there are my 20 movies in my local Mongo database. Right, that's that. Moving on to testing. Well, from a kind of structural point of view, the advice is to have one test file per endpoint. And I guess we saw that in this week's lab. So in my sample web API there, I have 3 endpoints. I have a genre endpoint, a user's endpoint, and a movie's endpoint. So I would expect to have 3 test files corresponding to those. Now, I've only written tests for the users and the movies. And so if I go into my test folder, and this is essentially what you did in this week's lab. Where are my tests? There. So here are my movies tests, and I've got some user tests as well. As always, it's really important that each individual test case is completely isolated. Now, what that means is, in the context of a web API, it essentially means we need to reset the database before each test case. So we need to destroy all of our collections or tables within the database, reseed them, and we need to do that before each individual test case, i.e. before each individual it block within my set of tests. So now I intentionally left databases out of this week's lab, but we eventually have to address it. And so if I look inside this test file, and here in the before block, what I'm doing is I'm making a connection to the database itself. So my actual test is connecting directly to whatever database is being used by the web API. It's kind of bypassing the web API and connecting to the database itself. And it needs that. I need that connection because I am going to be manipulating the database from my test code, as in putting seed data into various collections or tables, wiping them clean after each test case. So, okay, I've made a connection, and DB now is going to be my direct connection to my database. I've got an after hook. I'm not sure if I've used the after hook with G at any stage in our mock tests. The after hook, as you might expect, executes at the end of once all of my test cases have executed. And what am I doing? I'm essentially dropping the entire database. I am wiping it entirely, which makes sense because the next time I come along and I want to run my tests, I want to start all over again with a clean database. I don't want to have any kind of overflow from one execution of my test to the next. I also have a before each and an after each. And in the before each, what I'm doing is I'm putting data into, in this case, I'm putting it into the movies collection. Now, if I scroll back up, you can see as well here that I am accessing my Mongoose schema directly from my tests. So a lot of the code that I have here that involves manipulating the MongoDB database is similar to the code that your web API uses to manipulate the database. So movie in my case is the hook, that is the object that I'm going to use if I want to talk directly to the movies collection within my MongoDB database. And you can see here, I'm actually at the beginning of each test case, because before each runs at the beginning of each test case, I delete the current records inside in the movies table or collection, and I populate it with some fresh data. The fresh data that I'm populating it with is the set of movies that I have stored as part of my kind of seeding. You can see here I'm populating it with this, and where does that come from? Movies is here. So I'm digging it out from my seeding data that I have. So that's in my before each. So I repopulate the database, and in my after each, what's actually happening here is nothing to do with the database. What I'm doing is I'm shutting down the Express server at the end of each test case. So that's again linked to this idea of this notion of test isolation. I want my Express server to be a fresh or new server instance, new Express instance at the beginning of each test case, at the beginning of each it block. Okay, that's that. And then it's a case of the individual test cases themselves. And I don't need to talk over those because we've already seen this kind of code. So it's more that kind of test isolation principle, and how that applies here is the need to kind of reinitialize your database between each it block execution. Now I will be giving you this code as part of next week's lab, and that will be the starting code for the assignment. So you'll need time to just browse through it first, make sure you understand it, and then you start building on top of it. Moving on to CI/CD. Continuous delivery, we know what that is. The idea is that we have a new version of our web API in this case, and each new version can potentially be made can potentially be be deployed to your production environment, but the decision to deploy it is a manual decision. It's not automatic. That's this idea of continuous delivery, whereas with continuous deployment, once our web API goes through the CI/CD pipeline, so we do a build, that's clean, we run our tests, they've all passed. We then deploy our web API to what's called a staging environment, and then automatically we deploy it also to our production environment. That's with continuous deployment. It happens automatically. Whereas with continuous delivery, we only deploy it to our staging environment. The staging environment is a deployment of our application to an environment which is accessible to the development team itself. It's not accessible by our end users. The production environment is what our end users avail of. So anyway, we know what these two concepts are anyway. We haven't really practiced them though, because in our first assignment, we only went as far as continuous integration. We didn't really do continuous deployment. How do we achieve this CI/CD? Again, we know all about this really from before. We make sure that our team are continuously integrating their new code into the overall application, the application in this case being our web API. The importance of running our automated tests every time we integrate some new code into our application. And step 3 is where I really want to try and focus on from here on in. Once all our tests pass, then it's important that we deploy our built version of our application into what I'm calling a production-like environment. And the technical term for that production-like environment is a staging environment. So what this would really mean in the context of what we do in the labs is we are going to be deploying our web API to the Heroku platform. In fact, we're going to be potentially deploying two versions of our application to the Heroku platform. One of the deployments we will refer to as the staging deployment, and that notionally is just the version that's available to the development team. The second deployment will be to a production environment, again on Heroku, and that's what's going to be available to the end users. So we deploy a build of the application to a production-like environment called the staging environment. And what I'm saying here is that, well, yeah, once you've deployed it to the staging environment, then the decision as to whether it should also be deployed to the production environment is either a manual decision or it's automated. And that's the distinction between continuous delivery and continuous deployment. So I'm saying here we can release the new version of the application to the production environment at any stage, but whether that happens or not depends on whether you want to follow continuous delivery or continuous deployment. So why, I hope we know why this is all a good idea. We've seen this diagram before. So if we're just talking about continuous integration, then this is kind of the sequence now. I did say to you when I showed you this diagram before that what we actually do in our labs here is slightly different. But in general, the stages of your pipeline, if all you're aiming for is continuous integration, is you have a build stage, and we know what build now means now in the context of a web API. Typically, the next stage after that in our pipeline would be to run our unit tests. Now, we don't have unit tests, so we're kind of skipping that. Provided all the unit tests are successful, the next stage in general would be to automatically deploy this build version of our web API, deploy that to our staging environment. In our case, that would be deployed to Heroku. And in general, then what happens is you run a whole series of tests against the deployed version of the application, or against the staging version of the application. So again, without overdoing it now, our pipeline is we have a build phase, then we run our integration tests, our web API tests. And what we'll be doing in next week's lab is then we'll be deploying it to our staging environment. We won't have this stage in our pipeline. Now at this stage, if I flick over back again to my source code and I look at my GitLab, because GitLab is the platform that we're using for our CI/CD, then again, this should look fairly familiar. Just 1 second now. So if we look at the stages, really, again, we've got where are my stages? Oh yeah, we've got an install stage where we're just going to be installing our node modules. We've got a build stage. We know what that's going to translate to now. We've got a test stage. That's where we're going to be running our tests, our web API tests, which you've done in this week's lab. And we have a deploy, oh, sorry, I've called it a staging stage, which is really a deployment stage. Here are the individual jobs. Here's the install job, where I run npm install essentially. And the output, sorry, now just let me check this. Oh yeah, sorry, yeah, okay, that's the install. The build is where I run the npm run. Well, I've decided to run npm run clean separately. Didn't really have to. Then I run npm run build. As you know, the build actually, when I showed you the build script, it actually does a clean anyway. So this is, I guess this is redundant, that line there, but it's okay. So we now know what npm run build does. It generates the build version of our web API. And if I just scroll back up, you can see here in terms of my caching, I'm caching the build folder. So that means that the build folder will be available to other jobs. I'm not passing it on as an artifact separately. And also the node modules folder, because I'm caching it, is available to all jobs within my pipeline. So that's the build job. Nothing new there. Our test, obviously enough, is going to run our tests. I didn't do that locally, but you've done that in this week's lab, so there's nothing new there either. And finally, then we have our deploy. And before I talk about that, I'm just going to go back to my slides. What am I doing on time? Okay, so continuous integration, continuous delivery. We're not really interested in this stage here. What we're kind of interested in is how do we transition from this stage to this stage in the pipeline. So we know what this stage is. This is where we deploy our web API to an environment, cloud environment, and thus making our web API available to our production team. Now, the decision as to whether this stage in the pipeline should execute or not, that is, if you can see here in the arrow and the little caption I have in the arrow, the caption says manual. This is a manual step. It's not automatic. So somebody in the team has to essentially kind of click a button, and the clicking of that button will cause this stage in my pipeline to execute. And what that stage does is it deploys whatever was the output of the build, it deploys that to the production environment, and therefore my web API is now available to whoever my customers or my users are. That's this notion of continuous delivery. Whereas with continuous deployment, again, we're not interested in this stage. What we're interested in is how do we go from here to here? And with continuous deployment, it's automatic. Okay. Once the deployment was successful, and of course the testing was successful and the building was successful, once all of those succeed, then automatically the new version of the application is automatically deployed to the production environment. Clearly, it's only software houses that have been using CI/CD for a number of years would employ continuous deployment. Many software houses are still at the kind of continuous delivery stage in their evolution of their CI/CD CI/CD kind of experience. Okay, back again to how does continuous deployment actually work, whether it be to staging or production. So this is where Heroku comes in, and I've got, well, before I look at Heroku, here's my GitLab project corresponding to what I've been showing you there in VS Code. Here's my pipeline. This was the install stage. This was the build stage. This was the test stage. This was the deploy stage, where I was deploying to Heroku, and it looks like it was successful. Now, what I needed to do in Heroku before I ran my pipeline is, sorry, let's go over to Heroku. Here's Heroku, and what I needed to do was create an empty app, to use the language of Heroku, and this is what you will be doing in next week's lab. you create an empty app, and then in your GitLab configuration, you have to implement the automation of the deployment of your web API to that app. So once you've created the empty app, we're back to our CI/CD pipeline, and we have this new stage here. Now, in order to deploy an application to Heroku, we need to use some command line utilities. And that's what's actually happening here. There's a utility called DPL, I presume is short for deployment. It's a utility that is written in a language called Ruby. It's not written in it's not a Node kind of utility. So what I'm doing here is I am, first of all, when we can kind of ignore this line, what I'm doing here is I'm installing the Ruby language itself, and I'm then installing the utility that I want to use, the Ruby utility that I want to use. If I just scale back a little bit, you can see here that the image I'm using for this particular job in my pipeline is not a Node-based image, it's a Ruby-based image. And again, like if I go back up to the very beginning, the default image that I want to use is this one here. So in other words, that's the image that is used by all of my other jobs, my install job and build job and test job, because all of those are using Node. And so I want an image that has Node already installed in it, which is why I've chosen that one. But for the deploy job, I need to have an image that already has Ruby, the Ruby language installed in the image. And the one I've chosen is that one, Ruby latest. So just a slight correction of what I said there. So this image will contain the Ruby language installed in it automatically. And then I'm availing of that fact to allow me to do some Ruby specific installations. So it looks like Ruby dev might be some sort of utility, and definitely DPL is a Ruby utility as well. I couldn't install DPL directly. I had to install this prior to it. So essentially I just found this stuff on the web really as to how I would go about this. So once I have DPL installed, here I'm actually using it. And this is the line that allows me to deploy my web API, the build version of my web API, up to Heroku. We could easily run this command from the command line. That's provided we had Ruby installed on our operating system, and that can be done, but it's a little trickier, and I didn't want to burden you with that. But this is essentially a command line instruction. So if we had Ruby, we could easily deploy our web API up to Heroku from the command line. Now, I'm conscious of the time now, and I don't want to rush this stage because this is essentially the new part of our pipeline. So I'm going to halt it here, and I guess the first hour of next week's 3-hour lab, I'll finish this set of slides, and then you can actually work through the lab. It's not going to be very long, but it will allow you to get the experience of creating an app in Heroku, running the pipeline, and hopefully deploying your web API, which I will give you. And it's essentially the Movies web API, deploying that to Heroku for yourselves. And then you have a starting base for the second assignment. So we're kind of in the middle of the story, really, at the end of this lecture, but that's okay. I'm going to halt it there, and I'll pick it up with you the next day, unless there are any questions. No.
Would you consider this assignment harder than the previous?
Uh, not really. You know, you're very familiar with testing. You're familiar with
Yeah, yeah.
GitLab. So it's only the latter part, this idea of auto deployment, or that's going to be new. The other part that's it's not so much new is you're going to be writing tests for the web API. You've got some experience of that from this week's lab. So it's only a case of writing some more tests for that part of the web API that I didn't include tests for in this week's lab. Plus, you're obviously going to be expanding the web API for your web app dev module. And you will need to write tests for me for whatever expansion that you've made to the web API.
Oh,
So I would wait until we see next week's lab. You've worked your way through it, then you've got a clear kind of understanding as to what might be involved in the assignment too.
yeah. Also, when is the due date for this assignment? How much time do we have?
He will be submitting it at the very beginning of January.
Oh, okay. Yeah.
Yeah, yeah. Yeah.
Perfect.
Yeah, you need time to get into it really. So it will be
No
the very
problem.
beginning of January.
No problem. Thank you.
Okie doke. So I'll talk to you next week. Bye bye.
Bye now.